Does the series summation k from 2 to the infinity k minus 1 divided by k cubed minus 1 converge? Here we start the summation with the value k equals 2, because if k equals 1, then k cubed minus 1 is 0, and the term k minus 1 divided by k cubed minus 1 would be undefined if k equals 1. Now we exclude this value and start with k equals 2. So does this converge? We solve this by simplifying. K minus 1 divided by k cubed minus 1 is 1 divided by k squared plus k plus 1. We have simply now cancelled out the term k minus 1, which is also a factor in k cubed minus 1. So we have that for all positive values of k, 1 divided by k squared plus k plus 1 is less than 1 divided by k squared. Because if k is positive, then certainly k squared plus k plus 1 is greater than k squared. Therefore 1 divided by k squared plus k plus 1 is less than 1 divided by k squared. If we make the denominator smaller, the whole expression gets larger. The series summation k from 2 to the infinity 1 over k squared converges. Therefore we conclude by the comparison test that also the series k from 2 to the infinity k minus 1 divided by k cubed minus 1 converges. So the answer for this problem is that yes, the series does converge. Look at the series k from 1 to the infinity 1 divided by k squared plus 4. Does this series converge? We argue in the same way as before. If k is greater than or equal to 1, actually for all values of k, k squared is of course always less than k squared plus 4. Therefore 1 divided by k squared plus 4 is less than 1 divided by k squared. And now the terms 1 divided by k squared form a convergent p-series, p equals 1. And therefore by the comparison test also the series summation k from 1 to the infinity 1 over k squared plus 4 converges. The series summation n from 1 to the infinity 1 divided by cube root of 2n plus 1 is somewhat more complicated, at least it appears to be. If n is greater than or equal to 1, then 2n plus 1 is less than or equal to 3n. If n is 1, then 2n plus 1 is 3n, otherwise it is strictly less than 3n. Therefore, we conclude that 1 divided by cube root of 2n plus 1 is greater than or equal to 1 divided by cube root of 3n, that is 1 divided by 3n raised to the power 1/3. The series summation n from 1 to the infinity 1 over n to the power 1/3 is a divergent p-series. And therefore also the series summation n from 1 to the infinity 1 over 3n to the power 1/3 diverges. We have established that 1 over cube root of 2n plus 1 is greater than or equal to 1 over 3n raised to the power 1/3, and that these terms 1 over 3n raised to the power 1/3 form a divergent series. Therefore also the original series summation n from 1 to the infinity 1 over cube root of 2n plus 1 diverges by the comparison test.